Can you hear me too?
I can hear you loud and clear. How are you
Okay,
doing?
awesome. Thank you so much for making it today.
No problem. No problem. And I'm really sorry about the scheduling two things that is not possible. But let's try to cover as much ground today, and I can meet you with you again starting on Wednesday.
Okay,
But hopefully today we'll get to cover as much as you like. All
okay,
right.
awesome.
So I know you have lots of questions, so let's go straight to the point. Oh,
Okay,
just to remind you, I'm recording this meeting just for data quality.
yeah. No, go for it. Awesome. Okay, do you mind if I share my
Go
screen?
ahead. Go ahead.
Okay, let me know when you can see my
I
screen.
can see it now.
Okay, so maybe there's two assignments that I started to work on. One is the statistics one,
Right.
and the other one is the data wrangling one. So maybe we can start with the statistics one.
Let's do
So
it.
yeah, so let me go to the point where I started to have questions. So I think like one of the questions you kind of answered, and it was for part two. That's when I started to become a little bit unsure about some of the things.
Okay.
So so um, So, uh, 1 second.
Yeah, no problem.
I'm just because I didn't look at this for like 3 days or something. So
Right.
the other assignment, so I have to just like check real quick. Okay. Oh, right. So this is still running because I just rebooted my computer.
Right.
But so there was some concern about like my p-value. I
Okay.
So this J question, which is asking at, what proportion of the P difference is greater than the actual difference?
Okay.
And when I was going back to the lesson, I thought that this is, the way they're doing it in the lesson is by using this code to look at that. Maybe this is the wrong code for
Okay.
that, but let me see why it's loading so long. Maybe it's this thing here.
Yeah, might be the bootstrapping. Oh
Yeah.
no, it's on this. Um, okay, it's not.
Let me just check where it's. Oh, it's yeah. So I'm doing like many bootstrappings here, and I don't know if that's what it's asked for, but like in the
Uh,
first one, yeah.
let's go even a little bit behind that. Can you walk me through the whole part two, please? So that I
Yeah.
know what your variables stand for, and then I can truly understand what is going on here.
Okay. So perfect. Let's do that. So
Okay.
part
So 1, 2, let's go to 2.A. There you go. A. So what is the convert rate? And what you have there is p new equals to df converted dot mean, which is perfect because the new p, it means that we just want the average of everything that was converted. Awesome. Let's continue. Then B, for the old p, you're making it equal to the new p, which is great because that's what's been told in the first paragraph. Awesome.
Yeah.
Let's continue. So what is n new? And what you got there is, can you scroll down a little bit to see to,
Yeah, so my question was also that, initially the way I understood part A and part B
right?
is, so I thought that they're asking for the conversion rate on on the old page versus the new page, but so I didn't really understand that they were just looking at, regardless of what page you are, what was the conversion rate. That looks to be the question here.
Yeah, so in the it says on part two, point number two, it says assume under the null hypothesis that p new and p old both have true success rates equal to the converter success rates regardless of page. So basically, your null hypothesis is that both the old page and the new page convert the same. So what we're trying to get here in p new and p old is basically a null hypothesis, making them equal so that we can simulate some results based on that premise that both have the same conversion.
I
So
see.
that's why we are making them equal. There's no need to do anything else. This is like a simulation if both were equal. So it's not going to be like a true result based on the data. It's just going to be, let's imagine that both conversions are the same. So that's
Got
all we're
it.
doing.
Got it.
Okay.
So then I'll just put a comment here. Then pretty much we didn't.
Yeah, not needed. Awesome. Yeah, cool.
So then
let's go with C. What is, and because the A and B are correct. And new, it says what you got there. So basically what you're doing is you are querying all the landing page that is equal to new page. And okay, that might be different from what I got. So the result for n new, basically what we're doing, where we're looking for n new and all, what is it? What are we looking for?
So my understanding is they're looking for the number of times, right, that somebody landed on the new page.
All right. It's not as, I mean, yes, who's landing on the new page, but it's more in the DF. You have actually you have a DF a little bit in the where it says 27. As you can see, you have a group and you have a landing page.
Yeah.
So the NU is not just looking for the landing page, but it's looking for the treatment group. It's basically who are the people that we randomly assigned the landing page to, either the new or the old one. And then we have a different group, which is the control group. And the control group is basically everyone that we assigned for sure the old page.
Oh, so then this is by group, not by landing page?
That's right. That's by group. Because since this is an A and B test, we're basically looking for, in science, you always will have a control group and you will have a treatment group, which is the one that actually undergoes the real test. So yes, that's basically going by group, not by, there you go, that it is. And if you run it again, can you run it again to see what you get?
Yeah, I think this bootstrapping thing is like
no, that already ran.
there's another one, right?
Yeah, it must be another one.
This one here.
Yeah, oh yeah, it's another bootstrapping.
But that's probably almost done. And look, they wanted me to do 10,000. I'm doing 1,000. It's already taking so long. But
wow.
Yeah.
It's fine. And now it looks correct. A group equals treatment, and then you have group equals control. That's what we want, and you'll get similar results. For example, for the and all, you will get exactly the same result, which makes sense because all the control groups landed in the old page. But let's continue, and then we'll go back to check the results. All right.
And then my other question is, why do we not do n unique? Because what is if like this? I mean, I don't know. I haven't checked, but what is if the same user was on the?
Yeah, that's good. Actually, yes, that was my mistake. I didn't tell you, but yeah, and unique is great. You should change it.
Okay. Perfect. We got that.
But nice catch. Nice catch.
Yeah. Thank you. Okay, so then.
But you can use n unique. I think you just wrote unique, but you can use n unique. That will give you the number instead of the unique IDs.
Perfect. Let's do that. Awesome. So then I think this is good, right?
Yeah, it's looking good. Let's go with E. It says simulate n new transactions with a convert rate of p new under the null, and store these n news ones and zeros in new page converted. All right, so we just basically would like to simulate the n. We would like to simulate the transactions, the number of transactions we have in NU with a PNU, and there's actually another way to simulate those. Let me share that code with you through the Student Hub. Do you have access to it?
To where?
A Student Hub, where our chat.
Yeah, I have it here.
Okay, I'm going to I'm going to paste some code there. You can use that code to simulate it as well. So that's going to be faster.
Oh, so hold on. So then I can just simulate instead of cell 28.
Yes. So what this code is doing basically, it's saying give me the number of simulations that is in the first variable, which is n new, and I would like to have the average of the second variable, which is the p new, which is your conversion average that you already got. So that's going to simulate those number of transactions with that average.
Oh, okay. Got it.
All right. And then for F, you can do the same, but this time you can use the same code, but you will have to do different variables. You have to use the N old and the P old.
Yeah. So I just want to understand what we're trying to really do here. So is this basically, we want to simulate like a distribution that gives us like a better picture of the conversion rates for each of the landing pages instead of just like a raw average that doesn't mean much? Is that what we're trying to do, or?
Yes, we're trying to get distribution. There you go. That is.
Okay. So yeah, then I can do the same thing here. But do you think like in theory, like this code and your code should produce a similar distribution, or?
Let's see. You have a size df. The only thing I'm worried about is that you're taking the df sample size of the whole thing, of the whole data frame, and here what we really want to do is just get the size of the n new.
So the size is also not right here.
Right. Because that's what is given in the instructions that says simulate n new transactions.
Yeah.
So, because that's the number of people that is in our treatment group. So right. So you have to imagine as the treatment group is, let's say you have 50 people in the treatment group and I don't know, like 50 more in the control group. Right now in the size, you are taking the whole group, the 100, but you really just want the ones that are in the treatment group and then the ones that are in the control group.
Yeah. But what would it be, because like, let's say this is obviously wrong what I'm doing is, but in the next step, I'm saying like, let's say out of all these, the sample size of whatever 100 people, everybody,
right,
I want to pick the ones that went on the new page and then who converted. Like, would that not kind of correct it? Or, I mean, I guess I'm not understanding really. How detrimental the size problem here would.
Right. I will have to take a good look at that code, because the thing with the random binomial is that it's really short and clear. Like, oh, I'm going to get a distribution that is this number of this long, and that is going to take an average. At the end of the day, the average of that entire distribution is going to be the p new or the p old. So this one, I'm not exactly sure how you are establishing the size, the number of results you're getting, and how you are getting the average.
Yeah, but that's fine. You know, I can just simulate it later on to change the size and see how that compares. Just
right.
So we don't have to waste time on this right now, since we answered this pretty much.
Now for the F, it says simulate and all transactions. So that's basically you need to change it to your variables to n old and p old, but you can use the same code that you use in E.
Right. And then as far as these graphs goes, obviously this is not right based on my wrong code, but like, so your graph for these things, I guess there's one question Yeah, let's get to, I think there's one question specifically asking for the graph, but
Right. Let's go with that after let's keep going, and then we'll get to the graph.
okay,
All
then
right.
G.
So G, find P new minus P old for your simulated values from part E and F. So basically, what you can do is just you will have so you need to get the average of, then how can I phrase this? All right. So in part E and part F, you're getting simulations that you will have an n number of simulations.
Yeah.
That if you take the average of those, it's going to give you equal. Can I share my page a little bit so that's going to explain that? Okay. I think you need to stop your share, and then there you go. Okay. Can you see my code?
Yeah.
Awesome. All right. So what we're getting, where we're at. Okay. So basically what we're saying here is, give me this number of simulations. And at the end of the day, if I want to take the average of all of those simulations, I should get this. All right. That's basically what it's saying.
Yeah.
Okay. So when it says find P new minus P old, basically what we're doing here is I'm taking all the simulations that I gather from NU, and I'm just getting the average.
I see.
All right, which is going to be P new, basically. All right, and then I'm going to subtract the P old, which is basically all of those, all of the simulations, and I'm going to divide it by the average. By the end. Oh wait.
Okay.
By the number of simulations, and then I should get the average. All right.
Yeah.
And you will have a small difference there because these are simulations, so it's not like a perfect distribution that is going to give you that.
Yeah. Yeah.
All right. But that's basically what it's saying.
Okay. Yeah, that makes sense. Let me take a note, or if you feel comfortable pasting that code, or I can just make a note of this code.
You can make a note. I cannot share like the whole code, but you can definitely take a note of it.
Okay.
And if there is a specific snippets that you want me to send you, I can actually do that.
Okay, no problem. 1 second. Okay, I got that.
Okay,
yeah, that was
really
helpful. Yeah, because I didn't know they wanted me to subtract the respective averages from each other. I thought,
right, because what you have to think is n is going to signify, or is always going to mean a number of cases of observations, and p is going to be an average always. So if you think it that way, it makes a lot more sense. So basically, this is your p for the new, and this is your p for the old.
Awesome, nice, thank you for that.
No problem. Let's continue with H, and we're almost in the visualization. So it says simulate 10,000 P new PO values using the same process similar to the one you calculated A through G. I store all 10,000 values in a NumPy array called pdifs. So first, I created the pdifs array, and then there's a simulation of 10,000. And basically what we're doing here is we're creating the simulations for we want this number of simulations that average these P, and then we're doing the same for the old page, this number of simulations. This is our control group. Okay, and once I have both distributions, what I want to do is I want to get the difference of the first. So what I'm getting is here, I'm getting a distribution for the treatment group and a distribution for the convert group. And I want to get the average conversion rate for my treatment group and my average conversion rate for my control group. And I want to subtract both. So basically what we did in steps from E to G, right? And I want to capture that difference in distributions in my array. And I'm going to do that 10,000 times. That's basically what this code is saying.
Right.
right? And once you have it here in an array, it's really cool because you just can plot it. And so it's really easy. And the cool thing about the bootstrapping is even though sometimes you will get difference such as this one, for example, the first time we got a difference of minus 0.00148. Okay,
Yeah.
at the end of the day, Bootstrap gives you it's centered, so it makes it a bell curve.
Yeah.
So and this is basically your null hypothesis that there's no real differences, and we can see it here.
How do you see that? I don't know how we.
Oh, here's a 0.
Yeah.
And as you can see, most of your differences fall here.
I see. Okay. Interesting.
Right? Yeah, that's really interesting. And so this is basically the curve that you will see in the null hypothesis.
Got it.
All right.
Yeah.
And then it says what any questions so far with this part of the code?
No. I think it's nice you have like a more efficient code with the NP random binomial. I wish they would have. I don't know. Maybe I missed it, but
No, you didn't miss it. First time I submitted this project, I wrote like a gigantic code just as you did, and my reviewer shared this with me, and it changed my life.
And now you changed mine. Thank you.
Well, I'm just passing the knowledge.
Yeah.
All right. So Jade says, what proportion of p-diffs are greater than the actual difference observed in AB data, CSV? So what we're doing here is what proportion of the p-diffs are greater than the actual difference observed in AB data? Now we're comparing our null hypothesis to the actual data that we have here. So I'm basically making sure that this is an array. This is my difference from this code that I got in this code.
Yeah.
And I'm saying, okay, let's watch the actual difference. So right now, here I'm getting the average of my treatment group that actually converted. And here I'm getting the average of my control group that actually converted. So as you can see here, this is different from what we did over here. Because here we're basically saying, oh, P mu is going to be equal to P all.
Yeah.
But here in our actual data, we're saying, okay, let's not do that anymore. Let's actually see what is my conversion in the treatment group and what is the true conversion in my control group.
Right. So now we're breaking it down really by the groups. And in the beginning, we said in the beginning we assume they're the same, and now
exactly. And now we're not assuming. Right. Okay. And now what we want to do is say, okay, in reality, how far are my actual differences? These are the real differences.
Yeah.
From the difference that I made up, imagining that both conversion rates were the same for the old and the new page.
Yeah.
Okay. And we can see here that we have a 0.91 and a big number. Okay. And it's asking, what have we just computed here? And what we just computed is the p-value. And that is the probability of finding our updated statistic given that the null is true. A p-value this large suggests that it's really likely that we will find our observed statistic from the null. Thus, it fails to reject the null hypothesis that there is no differences between the new and old pages. So we have a 0.91. So that means that what this basically means is that the difference between these two, most likely we're going to find it in this distribution.
So there's no significant difference?
So there's no significant differences between both. Because we have like a super large p-value over here.
Right. Cool. That's amazing. It makes all sense. Very cool.
All right. So then from there, it says we can use a built-in to achieve similar results. And so basically here you have to fill out, you have to look into the documentation of stats models, and you're going to create some models. So as you can see here, I'm just basically saying, okay, give me all the persons in the control group that converted, and let's add that together. Now give me everyone from the treatment group that converted, let's add that together. And then it says, okay, tell me everyone that landed in the old page and all the people that landed in the new page. Okay. And now that I have all the ones that converted in the control, or the ones that converted in the treatment, all the ones that landed in the old page and the new page, you just fill out this this code, and it basically is magic because it calculates everything for you. So as you can see here, we're getting a similar result that we got over here. It's not the same because this one is actual simulations.
Yeah.
But it's pretty close, and it's just like 2 blocks of code. So this is really cool.
That's interesting. So what do you prefer? Like if you were to choose one of the two? Or
I would do both, actually. I mean, it's not that big of a code. But at the end of the day, this model sees the future. So yeah, I would go with this models. But I mean, I would try both. I think it's interesting to see both approaches.
Right. Nice. Cool.
And here, I would encourage you to look at the documentation, and it pretty much explains why you have to put everything where you have to put it. And the cool thing here is that you get a p-value, which is this one, and you get a c-score. And the c-score, when you look at the documentation, the c-score gives you a critical value. And basically it says, if you exceed this critical, and you will find a table. If you exceed this critical, let me see if I can find it for you.
Oh yeah, I know. I remember what.
Okay, awesome.
Yeah.
Okay. So if you don't exceed that critical value, you fail to reject the null hypothesis. So that's basically what it's telling you.
And Javier, why do we do the z-test and not the t-test? Because I remember t-test compares 2 different populations with each other for something. So why z-test?
Right. That's a good question. So t-test, I mean, t-test is super useful as well, but I don't think it's going to be that useful for such a big data set. So you should look at t-test limitations, and it says like when you should use it, when you should use it. And let me see. So when data violates the assumptions, it may not have reliability. So it says like data needs to be collected from a representative random selected portion. Data is normally distributed. The 2 pillars have the same variance. So you have to have some certain assumptions that you meet always. And I'm not as I don't remember as much from these data set if it follows those assumptions. But it might be the case that the t-test is actually a good choice for this one.
So it's not definite that they say this is the right one, is z-test. It could be maybe other options too.
Exactly right. I mean, it's up to you to decide. I just feel that they wanted to go this way so that you can practice bootstrapping and you can practice this code of the C score. But at the end of the day, when you're working with real data sets, it's going to be up to you to say, okay, which test is going to be optimal for this data.
Cool.
Tina, I know you have more questions. We are done with our 30 minutes. I'm going to open a new spot for you starting on Wednesday. So I'm going to give you some options for either Wednesday, Thursday, or Friday. A specific standard time, your time zone, or which is your time zone?
PST, yeah.
Can you make it mornings or noons, or what time do you prefer?
Yeah, I'm flexible actually. So, so I guess, yeah, there's still the second part for the statistics one. And then for the other one, for the data wrangling, I have problems with querying the data from the Twitter API. So those two, yes, we can discuss next time, hopefully.
Yes, we can discuss them. If you if you are like stuck and you really need some help to keep going, I would suggest you just take a print screen of your code and share that with me through the Slack channel, right?
Right.
And I will try to answer as thoroughly as possible. But yeah, so let's do both things. So you can share your code with me through here if you're struggling with a certain question. And I will open tomorrow. I will open new available spots for you on Wednesday or Thursday, so that we can discuss whatever questions you have left.
Cool. Thank you so much, Javier. This was so helpful. I'm so sad. It was just that we don't only have 30 minutes.
I know, but let's use Slack as much as we can this meanwhile. And I think you're doing a great job. And I needed to ask these 3 questions. How's your progress coming along? Changes we need to make to your learning plan, and what can I help you today? But we don't have enough time. But I'm just going to write that we covered this and that you now feel like you can move forward. Is that okay?
Yeah, let's do that. Okay.
All right. Tina, it was great talking to you. Talk to you in a few days.
Okay, talk to you soon. Thank you so much, Javier.
No problem, Tina. Bye.